Okay, just for a second, picture it. You're floating in the absolute blackness of space. You look one way, and there's Earth, this stunning blue marble hanging behind you, and then you look the other way, and there's the moon, your destination. But getting there, it's not as simple as just pointing and shooting. The whole 10-day journey is balanced on a knife's edge, a true razor's edge. Let's dig into what that actually means. This is really the heart of the problem, you know? It all boils down to this. You've got one single critical engine burn that dictates the entire 10-day trip, and just one mistake, even a tiny one, can unravel everything. The pressure, honestly, is just unimaginable. All right, so let's zoom in on that one moment, that one perfect burn. It's a maneuver with a very specific, kind of cool name, and it is without a doubt the single most important thing you do after leaving the relative safety of Earth orbit. This is where the mission really truly begins. Trans-lunar injection, TLI for short. Now, it sounds super technical, right? But think of it like the most epic, high-stakes slingshot you could possibly imagine. It's one perfectly timed, perfectly aimed engine burn that literally flings the spacecraft out of Earth's gravity and sends it hurtling across 250,000 miles of empty space on a path that will, hopefully, cross paths with the moon. And this is the part that is just so hard to wrap your head around. There is only one shot. One. That's it. You don't get a do-over. After those engines cut off, that spacecraft is basically just coasting. It's a bullet fired from a gun, and its entire 10-day path is determined by that single violent moment of fire and thrust. So, if you only get one chance, what happens if it's not absolutely perfect? Well, in space, there is no such thing as a small mistake. Every single error has a cost, and that cost adds up fast. And boy, do the consequences escalate. The tiny miscalculation in that burn, well, now you have to use precious fuel to make course corrections later on. A little bit bigger of an error? Uh-oh, now you don't have enough fuel left to actually land on the moon. And a really bad error, the moon's off the table completely. The mission is no longer about exploration, it's about survival. And this just nails it. These are the three currencies in space that you cannot afford to waste. Fuel is your ability to change anything. Time? Well, time is how much oxygen, water, and power you have left. And survival? That's what's on the line when the first two start to run out. An imperfect burn puts all three of them in danger instantly. So we know errors are bad, but the TLI burn can fail in two really specific, and you guessed it, equally disastrous ways. You can burn for too short a time, or you can burn for too long. Let's break down what each of those means. All right, so you've got two very different ways this can go wrong. If the burn is too short, you just don't have enough get up and go. You fail to escape Earth's gravity, and you just kind of fall back home. The mission's over. Abort. But if the burn is too long, you've got the opposite problem. You've got too much speed. You can literally overshoot the moon, miss its gravitational tug entirely, and just drift off into a much longer, colder, and way more dangerous path through deep space. And in that situation, the overshoot, the entire mission changes in a heartbeat. This isn't about science anymore. It's not about planting a flag. Every single calculation, every decision is now laser focused on one single desperate goal. It's the Apollo 13 scenario, right? The original mission is gone. The new mission is get home alive. And that's the question you have to ask yourself. Put yourself in that cockpit for a second. Mission control comes over the radio and tells you the landing's off. The moon is literally getting smaller in the window behind you. What do you do now? The flight plan is out the window. You're dealing with a whole new problem. Because here's the thing, a navigation problem that started as numbers on a screen back in Houston quickly turns into a very real, very physical problem right there in the capsule with you. All of a sudden, it's about the oxygen you're breathing, the water you're rationing, the battery power you need for life support. And yeah, even the filters that are scrubbing the poisonous CO2 out of the air. The clock is ticking, and every second consumes something you cannot get back. And even if, against all odds, the crew can stretch their resources and survive that long trip back toward Earth, there's still one last terrifying challenge waiting for them: re-entry. It is a violent, incredibly precise maneuver. You come in at the wrong angle, and you either burn up like a shooting star, or you skip off the atmosphere like a stone on a pond, lost to space forever. That one little error at the start could make a safe ending totally impossible. And that really leaves us with this final, powerful idea. We always celebrate the arrival, right? The landing, the one small step. But the real measure of success, the absolute triumph of engineering and the human spirit, isn't just about getting there. It's about making sure you can still come back